We have spent the last few years treating artificial intelligence like a brain in a jar. You type a prompt, it generates an answer, and then it stops. It waits for you. If you want it to do 10 things, you have to push it 10 times. But actual work rarely happens inside a chat window. Real-world tasks involve pulling a customer record from a database, cross-referencing it with a compliance manual, and routing a response for approval across different applications. AI agents are designed to bridge this gap. Instead of providing instructions on how to do a task, an agent can securely log into those systems and execute the workflow itself, from start to finish. This chart shows the return on investment organizations are seeing with agentic technology. For every $1 invested in building these systems, companies are realizing an average of $3.50 in return. These returns are driving a shift in how organizations allocate their resources. In 2026, the focus has moved toward integrating AI directly into the production line as a functioning part of the team. Let's trace how this works in practice. Imagine a customer submits a complex fraud dispute to their bank. Instead of sitting in a queue for a human analyst, that ticket goes directly to an AI agent. The agent operates on a cognitive loop: perceive, reason, act, and verify. Perceiving the claim triggers the reason phase. It deduces it needs the secure transaction history. For this data, it enters the act phase, using the Model Context Protocol, a secure bridge into external tools. Without a human typing a new prompt, the agent queries the bank's transaction database, locates the correct account, and extracts the exact data it needs to move the case forward. MCP takes a closed language model and gives it hands and eyes, allowing it to manipulate live, real-world information instead of just predicting text. But our fraud agent hits a roadblock. The transaction data looks suspicious, and evaluating it requires a deep understanding of both risk and compliance law, complexity that is often too high for a single general agent to handle alone. Via the agent-to-agent protocol, the primary agent delegates to specialized risk and compliance peers. They analyze data, debate findings, and self-correct errors to reach a verified answer. Finally, the network queries its episodic memory of past fraud outcomes to verify the current decision. This orchestration of specialized agents creates a system of checks and balances, ensuring that complex decisions are debated and verified before any action is taken. Back to our example, a complex fraud workflow that traditionally required days of manual review is fully resolved and documented by the agent network in seconds. This comparative data shows the impact of that speed across industries. We are seeing a 30 to 50% reduction in manual workloads across healthcare triage, legal review, and retail logistics. Because these agents execute real-world actions, a logic error or hallucinated fact can trigger a chain reaction, cascading into a widespread operational failure. To manage that risk, developers use circuit breakers. These systems monitor an agent's failure rate in real time. If they detect an anomaly, the circuit trips, halting autonomous action and escalating the case to a human. These safeguards are necessary because we aren't using these agents for single, isolated tasks anymore. They are becoming persistent digital employees that accumulate institutional knowledge over months or years. This is the constitutional memory architecture. It hard-codes core identity rules and operational red lines into an immutable foundation, ensuring the agent's base layer cannot be overwritten by bad data or malicious prompts. This combination of secure protocols, tiered memory, and real-time circuit breakers provides the framework for humans to guide and manage a digital workforce at scale.